Well, thanks everyone for joining us and welcome. I'm Mark Millard and I work in Kel's IT, and I'll be moderating today's session. For this session, we have David Southard, who is going to present on bringing order to chaos, documentation as code. So I'm looking forward to this one. We'll have time for Q&A at the end, but feel free to drop questions in the chat and we can kind of bring those back around. And so without further ado, I will turn it over to David.
Okay, let's start this up. So as we went over the intro, just to give another brief intro about me, I'm a software developer for the UW-Madison General Library Systems. I'm a mechanical engineer by degree and a software developer by choice. I've been doing Ruby since about 2009 and Elixir since about 2016. So firstly, I just wanted to thank everybody for coming to a presentation that's mostly about documentation. The problem we're basically trying to talk about today is that the documentation lies. So it's often incomplete. It might be poorly organized. It's often lacking constant context or has inconsistent formatting. It's hard to search other than maybe Control F or Command F. Can get outdated very easily. Duplication is an issue, and it takes time from other tasks. Basically, it's a Hydra, but the problem is it's a Hydra that changes. So you have some data that's static data. So maybe who are the stakeholders? Where's the code located? What services are running on the server? Where are the logs located? What packages does it use? What applications are installed? What's the host name? But you also have some dynamic data that might change, such as library versions, dependencies, when will the patching happen on this box, cron tasks, how many CPUs and what's their load. But the problem is it's changing, and it's changing constantly. So the answer that we came up with was something we initially called infrastructure as code, but then we thought about it, and then we decided to call it infrastructure as documentation. And the basic answers we wanted to address for that: data changes should be push-pull. There's constant churn on data, and trying to go and update it in all the different locations can be an impossible task. We should standardize on templating as much as possible, reuse code where it makes sense. Publishing should be simple. Something like, you don't want a simple curl post is all you really need, or maybe just dump it to a JSON file, pick that up, or scrape the data. It should be able to handle failures fairly easily. So this is one of the reasons we chose the language we chose, is that it gave us pattern matching so that we can handle bad data or we can handle incomplete data. And then also you would want to do things like, if you're generating code or documentation, you would want to be able to email on failures. It should be secure. We try to fit it into the authentication we already use, like Shibboleth and Manifest, use API tokens for uploads, and then manage as much as we can by CI. It should be searchable. We use Postgres, which gave us some features that we'll talk about in a little bit. And it should leverage existing things you already have. Like if you're given a host name, you should just do a DNS lookup to get the actual address, as opposed to entering it every time you need to enter it. And as for where the information resides, the most obvious is the endpoint. So things like VMs, maybe Internet of Things devices like Pis or iPads. Maybe in the cloud. Another place it might reside is orchestrators. So things like Puppet, Terraform, Kubernetes. Maybe you have a data lake like Prometheus or Graphite that can house a lot of data that you can access. It lives in the code repositories. So it might be something like test code coverage, project information, basic readmes, versioning, reports that you might create with a CI task. It can live in your stores. So for instance, if you use Vault, there's an API that you can access with a secure token and get more information as you need it. It can also live within your internal APIs. So for instance, data on internal personnel, or maybe there's some XML or JSON files that you generate, you can leverage that. And sometimes it can even live in the content management database itself. So information that you would use in other apps. So the general approach we use to gather the information is the orchestrators create the data. So we did have a hard requirement that we wanted a viewable file on the box. So we chose JSON as the data format because it's human readable. But then we come along with an uploader and then we pick that up. We used Elixir, but you could use something like a cron task that runs every minute or every half minute. We used Elixir because it gives us some more information, like we can do system information, we can get active polling, we can handle error fallback a little bit better, and most importantly, we can do system calls. It could also exist on your scrapers. So like Prometheus comes along and scrapes the information up at some interval and then offloads it to another database. The websites generally store and transform the data. We wanted to use the raw data and not mutate it. So that's another reason we chose the language we chose. And then some scripts might publish information, like on a deploy. After the deploy, you might have a hook that publishes information, and then you can use that in your documentation. So the website, essentially, we wanted one unified website. So we chose Elixir, and then we used the Phoenix framework, and then we leveraged the live view features of that, which gives us templating. Elixir as a language is functional and it's concurrent. So it allows you to do things like pattern matching fairly easily, and you can transform data with your typical functional things like MapReduce, filtering, or sorting. We wanted to make the data a little bit spicier. So if you have a host name, for instance, you might want to also add an IP address. So that's something you could easily add to the data that you upload. We wanted it to be searchable, so we chose Postgres, which gives us the full text search capability. We can do things like stimming with custom data dictionaries if we want. And then we wanted to store the data, as I mentioned before, unchanged. And then, of course, present the data. So the system ended up breaking down into these systems. We have GitLab, Prometheus, Graphite, some library APIs, and then we have our content management database, which we'll call GoldenEye, and then Grafana, and then Slack and Teams. And essentially it looks a little something like this, but in reality, it probably looks like this, but times 100. So you can imagine that gets quite complex pretty easily. This is an example of like the inbound upstream data, which would be simple JSON that then gets transformed downstream into a simple view. But you might notice that this data has a little bit extra information that probably doesn't need to exist, like the email, the phone number, the location. So when you take that out, all of a sudden your data gets a lot simpler. You get a nice unified view, and you don't have to manage a ton of stuff upstream in order to get the same effect downstream. The payoff for us ended up being, we could see the big picture. So like you can have a list of these types of boxes, and you can look pretty quickly and see that there's a memory problem on this test server, and you probably need to further investigate that problem. We centralized and mostly made the information real time, which helped reduce the entropy and the lag in understanding what's actually going on. It gave us more paths to debug. So like after an update, you would know I need to run these tests and double check that this stuff is happening. And it's all central source. It gives you the information you need to trigger alerting and notifications, and even some supplemental information that you might use like in your dashboards and stuff like that. And then there's special features like in using Postgres, you get full text search for free, which is basically like a Google search, but just in your database. And then some of the lessons we learned were that you should always have one canonical source of truth. Try not to repeat yourself. So identify that source and push from it up to your database. Try to keep things simple. So make your component types as flat as possible. Don't overcomplicate them. And in this case, we were able to leverage pattern matching, which was another reason I chose Elixir. Try to use existing software as much as possible. Prometheus is really good, Grafana is really good, and they're really good at what they do. The goal is to try to access the information, not spend all your time building the systems to access it. Even sometimes plain old JSON might be good enough for you. Try to use charts and diagrams where it makes sense. Mermaid charts are pretty awesome if you're using Markdown, and you can usually inject them and then they get rendered as a full chart, and they're pretty easy to make. Try to use continuous integration as much as possible. This allows you to all have access to the processes I'll update them and I'll see very easily what's going on. If possible, leverage GitHub pages. This allows you to do things like you can publish your code analytics, your code coverage, documentation for your application can be generated on a CI run and then published to a page. And then make sure that you clean up properly. This is something we still struggle with today. You're always going to have entropy, but the goal is to minimize it. And if your canonical source of truth is lying to you, that's a problem. And then lastly, plan for bottlenecks, because API calls can be great for one resource, but when then you scale that out to 100 resources, all of a sudden you realize your API is incredibly slow and you need to implement an entire caching structure. So be sure to plan for that. And then lastly, I have one selfish request, and that you try Elixir, because it gives you a lot of cool stuff for free. That's a very high level overview and the end of my presentation part. So I'll stop sharing. And then I don't know if we have any questions or not.
There's no questions in the chat at this moment, but does anyone, thanks for that presentation. Does anybody have any questions for David?
It's okay if you don't have questions too. We can give you that time back.
I have one question,
Sure.
David. Like, how much? It's like, what was sort of the project time on that? This is a lot of impressive work in my opinion. I'm curious, like the time frame of sort of this project, and maybe how many people were
over involved. It was mostly me and one of the attendants here, Christian, and we built it out over probably off and on with our spare time over a year or two. I know he did some more dedicated work as our DevOps, but it really didn't take much. And the website, I can't emphasize it enough, it's pretty simple. It's just a post request on a URL that you just save that data database, and then you present it in a UI, which is pretty easy to do. Grafana, you can find a lot of stock dashboards, so that part's not super hard. Probably the hardest part was setting up Prometheus, and luckily I had Christian at the time to do that. So
nice. Okay, cool. Yeah, I'll have to check out Elixir. So we have a question from Erwin. I don't know if, can you see the chat now?
Yeah.
Since you're not screen sharing anymore. Yeah.
What does it mean for a language to be concurrent? Basically, it means you could background a process and not have it interfere or block. I guess blocking would be a good way to say it. Agile methods okay, so I didn't see that. How would you say this is a good place to start? I would say start with Prometheus and then build out from there. Identify the points. I would say form will follow function, or function will follow form, one or the other. The data will drive what you end up with. And we got started by just incrementally implementing each piece and then seeing how it interacts with each other. Similar tools we tried. I think we tried some different PHP apps for the dev side, but essentially this whole project started as me wanting to learn Elixir better and doing it and then putting it to the side. And then Christian and others that I worked with basically said, hey, we want to use that project. So I guess experiment would be my takeaway from that.
Excellent.
And if you have any questions, feel free to email me. I know this was an incredibly fast talk in an incredibly short time, and maybe something hit you later. You can just always hit me up.
All right. Well, great. Yeah. So we're at 2:14. So yeah, feel free to reach out to David if you do have other questions. With that, yeah, thanks for attending, and we'll go ahead and wrap up so folks can jump over to the next sessions. So have a great conference.
Yeah, have a good conference, everybody.